What's going on, guys? Welcome back, and in this video I'm going to show you the proper way of handling features. Now I'm not going to talk about the usual stuff like async await. I think you already know that and you should be using async await. If you are not, please rewrite your code, please. So we will be using async and await, of course, but I'm going to talk about some advanced stuff that is also easy to understand. So let's just get started. So before I actually start explaining the optimization thingy, let me just familiarize you with the project that I wrote. It's just a console app, because we won't be needing any graphical user interface, so we're good here. Now we have three functions here called do something one, do something two, and do something three. Now all of these functions just basically wait for some time and returns nothing. It's just they does something in our application that's not dependent on anything, so it just runs there and it says I did something. And then we have another function here called read data. It takes around 2 seconds and it reads the data and it returns it. And then we have another function that takes the data and writes it, right? And it also takes 2 seconds to complete. Now usually what happens is when you are starting the application, you probably show some sort of splash screen and read the data from backend or from local database and do something with it. And what it does is it affects your app startup time. This is what we're going to target. Now of course I have like exaggerated a little bit, because in reality it probably won't take this much time, but anyway, you get the idea. We will be optimizing whatever we can so that we can squeeze in the last amount of performance for our application. So this is the naive way of doing it. You might be doing it in this way. So what we're doing here is we're awaiting for do something one and then do something two, and we're again reading the data, and we're of course awaiting here, and we have await on this too. Like basically wait every single step and do them one by one, right? And we can, if of course we can run this application, and like I said, it's gonna take 12 seconds, right? So 3 2 3 2 and 2, so 12 seconds. However, what we can do is we can use some internal API that Flutter and Dart provides to actually complete the features parallelly, wherever we can, to further speed up the process. Let me show you. First of all, you see this two function here. It's not really dependent on anything, and no other function actually depends on it. So what we can do is we can do this parallelly. So how can we do that? Well, it's actually very simple. So what we're going to do is await, of course, but instead of awaiting them separately, we combine them with something called future.wait. Now future.wait is a strange function. It takes two future, or sorry, excuse me, not two future but multiple future. It takes an array of future. So here we can actually pass all of the future that we want to await on. So I'm gonna pass in do something one and do something, sorry, do something two. So we pass those, and we're basically telling Dart or Flutter to complete this function parallelly. We don't really care when this which one completes first. We just want both of them to be completed before we run read data. So we're gonna go ahead and run this application again, and let's wait a little bit. And by the way, I'm using the stopwatch API to measure the program speed up program time. That's it. So as you can see, it did do something to first, and we don't really care. Like I said, it's independent. However, we now have speed up our application by 2 seconds. It takes 2 seconds less to speed up. So that's a good thing, right? And now let's actually continue, because we can actually squeeze out a lot more performance out of it, right? So we're gonna take these two functions. Now of course we cannot do them parallelly, right? This is where you have to draw the line, where you can or cannot use future.wait, because, well, you cannot complete this parallelly, because we actually need to first await on read data, get the data, and then write it, right? We cannot really do this parallelly. We have to do them sequentially. It's by the nature. So what do? Well, instead of keeping them here, what I can do is I can take this out of there and create another function. So let's say future and void, and we will call it, let's say transact data, or something that you like, right? And we're gonna of course create an async function, and we're gonna do this here. We're doing nothing. We're doing exactly what we did here, but we're creating a function. Why did we do that? Well, because now we can do this, right? Transact data, right? And we can also, because, well, do something also didn't depend on any of those, we can just take that, right, and we can pass it here, do something 3, right? And now if we run the run the application, let's see how long it takes. We're compiling and starting the application, and as you can see, it is doing completely randomly, but now it only takes 4 seconds to start the application, right? From 12 seconds to 4 seconds. That's the power of future.await. You just have to manipulate the function calls in such a way so that you can call all of them parallelly, and once you do that, you can squeeze out a lot of performance. You can speed up your application startup time by a fraction, a lot of seconds, right? So that's the thing I'm talking about. And I guess that's it. Actually, it's very easy to implement. All you have to do is manipulate all this data, pass them to future wait, and wait on the future.wait, and that's it. Yeah. So that's it for this video, and I hope you learned something. If you did, hit the thumbs up button. If you didn't, let me know how can I explain myself a bit more clearly. And yeah, see you in the next video.